Hi, welcome to this video on probability of simple events. In this one, we're going to learn how to calculate the probability of a simple event. Before we get to that, though, we have a bunch of vocab that I want to get through. This first one, talking about the set of all possible outcomes of a probability experiment, is referred to as the sample space. So that's all the different things that could happen in our little experiment. The next one is called an outcome, or outcomes, so the possible results. And we'll talk about those different outcomes in the next problems that we're going to look at. Our next one, a sample space in which all the outcomes occur by chance. That's called random sample. Right? And our last vocab on this page is a specific outcome or type of outcome, which is referred to as a simple event. So there's the vocab. I'll be using that vocab as we go through these next problems. But before we get to that, one more piece of vocab. You may have guessed this based off what's on the page, but this is our definition for probability. So the chance that some event will happen. And we're going to look at that as a ratio. Now, lots of different ways to look at ratios. We can look at them as fractions, decimals, percents, so on and so forth. So here is my probability. So what we like to do is we like to use a capital P, and then in parentheses we list whatever that thing is that we're calculating the probability for. And then how we calculate that probability, we look at what you want, so the probability of whatever event happening, how many of those things, we're going to put that in the numerator, and then in the denominator is going to be the total number of possible outcomes, like we talked about earlier. Now, here's our example. So I'm going to throw a bunch of marbles in a bag, specifically 5 blue, 10 red, and 10 green. And then we're going to pick one out randomly. So there's that, it's happening at chance. There's no skill in doing this. I just stick my hand in the bag, blind, I'm not looking at them, and then I pull out a marble and, well, what color is it? So in my first one here, the probability that the marble is green. So I would look at this and I'd go, probability of a green marble. Now, equals. Now remember, to calculate our probability, we're going to write it as a fraction. So I look at it, well, green, how many green marbles are in there? Well, there are 10 green marbles in my bag. And then I ask, well, how many are there total? Total marbles, there's 25. I just add them all up. 5 blue plus 10 red plus 10 green. I'm at 25. Technically, that's my probability, but we would never leave it that way because we'd want to simplify it. So I could simplify it. I look at this, and both of them are divisible by 5. 10 divided by 5 puts me at 2. 25 divided by 5 puts me at 5. So I could leave my probability as that ratio of 2/5. I could turn this into a decimal. 2 divided by 5 puts us at 0.4. Or I could turn it into a percent. If it's 0.4, remember, that's the same thing as 40%. So any one of these would be our answer for the probability that the marble is green. Well, what happens if I come up with something maybe a little more challenging? I want to know what's the probability the marble is blue or red. So it could be either one of those colors. So I come down here now and I go, well, probability that I have blue or red. Same way, make my ratio. My denominator, that's not going to change from the previous problem because there's still 25 marbles in that bag, and I pull out one. Is it blue or red? Well, now I have to look at how many blue or red marbles are there total. Well, there's 5 blues and there's 10 reds. I add it together, so there's 15 possible marbles that will satisfy this little problem. Now it's just a matter of simplifying. Both are divisible by 5, so I end up with 3/5. If I turned it into a decimal, it's 0.6. If I turned it into a percent, it's 60%. For the probability of getting a blue or a red one. I have another one. What's the probability that my marble is pink? Now that's a different problem. Probability that it's pink. Well, really, it's not any different. I go up here and I go, I'm going to make this fraction. The total number of outcomes goes in our denominator, which is still 25 because there's 25 marbles. And then I come up here and I go, well, how many of them are pink? None of them. They're red, blue, or green, so it's 0. So my probability is 0 over 25, which is 0. Turn it into a decimal, it's still 0. You turn it into a percent, it's 0%. Now, what that really means is it is impossible to pull a pink marble out of there, which I think everybody would look up here and go, that's kind of a no-brainer. There's no pink ones in there. Probability of finding a pink, yes, is 0. So there is no chance. So anytime you end up with a probability that's 0, guaranteed it cannot happen. And then my last one that I have on this page is, what's the probability that the marble is not blue? Not blue. There's a good one. Okay, so I'm going to write this out. I got probability of not blue. What does that mean? Well, I'm going to start here with my fraction. There's still 25 marbles in that bag. That's not going to change the grand total. But now I got to come up here and go, well, how many of them are not blue? Well, 5 of them are blue, but then we have 10 of them that are red. That's not blue, so that would work. 10 of them are green. That's not blue, so that would work. So then I look at it, well, I have 10 red plus 10 green. That puts me at 20 marbles that I could pull out of that bag that are not blue. And now it's just like all the other ones. Let's simplify our fraction. 20 and 25 are both divisible by 5. That's going to put us at 4/5 for a simplified fraction. As a decimal, we're at 0.8. And if we turn it into a percent, 80% that our marble that we pull is not blue. Now, this next little piece of vocab talks about the events of one outcome happening and that outcome not happening. So kind of think about the last problem we had, the probability of pulling out a blue marble and pulling out something that's not blue. So the opposites of each other, a lot of times I like to think of it as. Now, the other part of this, notice it says the sum of the probabilities of complementary events is 1. So if we look at, well, I kind of gave it away as to what this is complementary. So if we look at the probability of one thing happening and then the probability of that same thing not happening, if we add those two probabilities together, it will always equal 1. And here's my little example. It says one town has 10,000 phone numbers in use. So they're using 10,000. But then it goes on and says, of these, 500 are not listed in the local phone book. So what is the probability that the phone number you are looking for is listed in the phone book? Now, there's some things in here to be careful on. So I'm going to highlight a couple things. The first thing that I'm going to highlight in this one is right here. There's 10,000 phone numbers that are in use. Now, the next part is there are 500 not listed. The piece that we're looking for then is, notice here it says, what is the probability that the phone number you are looking for is listed? So we want the probability that it is listed. And I have two options down here because there's two ways to go about solving this problem. Just need a little more space. There we go. Right there, perfect. Okay? So option 1, I'm going to look at it this way. I'm just going to use the numbers that are in the problem. So really what I'm going to be calculating is, let's go, I need a color, here we go. I'm going to go probability not listed. And the reason that I'm doing this is because I'm looking up here and I see that there's 500 that are not listed. So I look at this and I go, well, make my fraction. The grand total always goes in our denominator, so there's 10,000 phone numbers in use. And then in this one, it tells us there are 500 that are not listed. So I'm going to calculate the probability that it's not listed. Now, I have 500 over 1,000. I'm just going to look at simplifying this fraction. I notice that both of these have the 2 zeros in them, so both of them are divisible by 100, so I'm just going to divide both by 100 right now. And now I'm down to 5 over 100, which when I simplify that, that's going to end up at 1 over 20, because they're both divisible by 5. So the probability that's not listed is 1/20th. But again, that's not what I'm looking for. I'm looking for what's the probability that it is listed. So this comes back to our complementary events. So I want the probability that it is listed, but I just calculated the probability that it's not listed. Well, the two of those together, remember, had to have a sum of 1 right here. Sum of 1. So then I think of this and I go, well, if they have to have a sum of 1, and the 1 probability is 1/20th, for me to get the other probability, I'm just going to have to take 1, and I'm going to have to subtract 1/20th. Okay. So then I can go back to, well, Subtracting fractions, they both have to have a common denominator. That would be 20. So this one we don't have to change. This one's going to have to become 20. 20 over 20 is 1. Now, what's 20 20ths minus 1 20th? It's 19 20ths. So the probability that my phone number is listed would be 19 20ths. Now, we could turn that into decimals. We can turn that into fractions, into percentages as well. But as a ratio, fraction, it's going to be 19 20ths. Now, I said there's a second option. Now, the other way to look at this is to go back to the very beginning, and we started with 1,000 phone numbers. We know that there's 500 not listed in the phone book. Well, then, how many are listed in the phone book? So I could take that 10,000 numbers that are in use. Let's subtract out the 500 that are not listed. And now we have, subtract that, 9,500 that are in the phone book or that are listed. So now I could just calculate my probability. So now I'm going to do probability listed. Well, grand total is going to go on our denominator again. That's 10,000. But then there are 9,500 that are listed in the phone book. So now I just have to simplify this fraction. Again, I'm going to start this off by looking at this. Both are divisible by 100, so I'm going to get rid of that. So now I'm left with 95 over 100. Well, I see that both of those are divisible by 5. And if I take 95 and divide it by 5, I get 19. If I take 100 and divide it by 5, I get 20. So notice, when it's all said and done, it didn't matter which way I calculated it. I still ended up with the same probability that the phone number would be listed in the phone book. Now in this one, we have Oakdale Junior High School has a total enrollment of 670 students. It says of these, 45 are absent today. Suppose a student's name is picked at random. What is the probability that the student picked is absent today? Okay, well, so then I'm looking at this and it says probability the student is absent. So probability, I'm going to call it absent. There we go. Again, probability, our grand total has to go in the denominator. So I'm going to go up here and I'm going to find, well, what's the total? That's right here. It says total enrollment of 670 students. That's going to go in the denominator of my fraction. And then probability it's absent. Now I got to figure out the absent number. So I'll come up here and go, well, it says that there's 45 that are absent today. So 45 goes into my numerator. Now it's a matter of simplifying my fraction. Let's come here. I look at both of these numbers and I notice that they're both divisible by 5. So if I take 45 and divide it by 5, I get 9. And if I take 670 and divide it by 5, I end up with 134. Now, if you want that as a decimal, if you punch it on your calculator, you're going to get a long decimal that just keeps going. But it's going to round to approximately 0.067. And if we wanted to turn that into the percent, we'd end up with 6.7% for the probability that a student would be absent that day at that school. Here's one that starts off and it says 800. Now notice it's written out in words. We just have to turn that into the number 800. Adults were asked whether they were planning to stay home for a winter vacation. Doesn't sound like a whole lot of fun. It sounds like it'd be way more fun to go somewhere on your vacation. But it goes on and says, of those surveyed, 560 said they were. So they were planning to stay home. So what is the experimental probability? And we'll talk more about experimental probability in the future. But for today, we can just think of it like we were thinking of our probability before. So it says, what's the probability that an adult planned to stay home for winter vacation? Okay, so we want probability to stay home. Again, probability. Your successful outcomes over your total outcomes. Total outcomes, I look up here and go, well, at 800 adults were asked this question, so 800 is our total. Then we got to find what we're looking for, the probability that it stays home. So now we need that number that represents the number of people that are going to stay home. Right here, we had our 560 said they were going to stay home. So 560 goes into our numerator. And now we just look at simplifying our fraction. So the first thing I look at, both are divisible by 10 because they both end in 0. And now I have 56 over 80. 56 and 80 are both divisible by 8. 56 divided by 8 should put us at 7. 80 divided by 8 should put us at 10. So 7/10 is our probability. If you want it as a decimal, 0.7. If you want it as a percent, 70%. And now I have one last problem, which is a little different. This one tells us over the past 3 years, the probability that a school math team would win a meet is 3/5. So it's telling us the probability in this one, where all the other ones, we were trying to calculate that probability. It then goes on and says if the team wants to win 12 more meets in the next 3 years, how many meets should the team enter? So this one I think back to going, well, how did I calculate probability? Because it gives us the probability to start. So I remember back and I go, well, probability was that successful outcome I like to think of, or the outcome that you want to have happen, over the total. So I look at this and I go, well, 3 over 5. So the 5 has to represent the total. The 3 would be that thing that we want to happen, in this case, win. And now I look at the other piece of information that we have in the problem. It says the team wants to win 12 meets. We want to win this many, win 12. Well, remember, we just said that the 3 was like how many we win, and then the 5 was like the total. So if we have this number up here that's 12 wins is going to have to be our numerator. And then notice it asked, how many meets should the team enter? So that's like our total number of meets that we have to. We don't know that. That's our variable. So I'm going to call that x. So I'm going to have this and then over x. And now we have this proportion, something that we've solved a lot of. So we just have to look at how do we want to solve it. So a lot of times I like to cross multiply, but sometimes we can recognize that pattern going horizontally or vertically. And I think that one works out really well right here. Because I look at this and I go, well, what do I have to multiply 3 by to make it become 12? And most of us very quickly will say, well, multiply by 4 and you're there. Well, then remember, then we'd have to do the same thing down here. Multiply by 4. And we just figured out that x, the number of meets we should enter, equals 20. So 20 meets. That should get us the 12 wins that we want. And that's going to conclude this video on the probability of simple events.